Hey, welcome. Today I'm going to show you how to get shading working as well as the shadows on a 3D object in Three.js. Let's start by creating a 3D object. So for that, first we go in Three.js documentations. So let's go in Three.js. So let's go in documentations and search for geometries. So we have different geometries as you can see, and let's choose what kind of shape we want to make. Let's try with the sphere one. So for sphere, this is how you create a sphere. So what are these parameters? Radius, width segments, and height segments. Okay, so let's take this code, and we also have a mesh. So sphere, and where am I creating my geometries here? So let's create sphere here. Let's see what that gives us. Huh. Okay. Oh, I already have been using this name. So geometry new, material new, sphere new. Okay, so what do we get here? Huh, we don't see the sphere yet. Maybe it's because the size is too big. So let's decrease the size. Okay, we got a sphere here. Let's push it a little behind. So sphere new dot position dot set 0 0 5. Let's see. Oh, okay, -5. Okay, so when you go behind, it's actually behind that object. So let's actually get it around -2. Okay. Let me turn this sphere off actually. That would be nice. Sphere. Let's turn that off. So now we have this. But we can see it's not projecting any shadows. Let's get this a little bit up as well. You can see it's not projecting any shadows even though there's a light source there. So how do we create lights, by the way? We go in Three.js documentation again, search for lights, and there's a different kinds of lights here. There's ambient light, directional light, hemisphere lights, and all these kinds of lights. So what for a point light we would like to use, as you can see, point light, like from a single source of point. So this light can cast shadows. So how do we create point light? Using this piece of code. So you just create point light, send in its color, its intensity, I think its intensity, and its distance. So if you also want, you can put in decay so that it goes away after a certain point of time. So I've already done this. Let me show you where. So let's say we have this left light, or the one that you're actually like moving up and down. This one. So I've created a point light here. Set its position, cast shadow to true. I've set its camera and near far. So you get the basic idea. So we got the point light here done. So why it's still not projecting any shadows? It should cast shadows, as point light just said. It casts shadows, right? So what's happening here? Might be something wrong with the material. Let's go and check different materials that we have in Three.js. Okay, so right now, what material are we using? Mm, Where did it go? Here new. We're using mesh basic material. Okay, so mesh basic material. You can see it's not affected by lights. Okay, so which one is affected by lights? We can use Lambert. This is for smooth shading. It is affected by light, but we'll not be using this. I'll explain a bit later. So we'll use mesh form material. So this one creates projects light, I mean casts light to itself, and also can be used to change into a Lambertian material. So let's use this. I'll show you how to change it into Lambertian material. So how do we use this? Mesh form material. Okay, so you just have this constructor. I guess we just use this. Change that to form. Okay, so let's see what happens here. Okay, it's still not casting shadows. Let's try this. Like the one we did there. New dot material dot cast actually dot cast shadow. True. Let's see if this works. Okay, now we get shadows for the sphere. Nice. So we got the shadow working. You know how to create light now. You know how to get the objects created. So now let me tell you why I used a foam material instead of a Lambertian material, which I could have used, which would have done the same thing. But now, since we want to change the shading modes in this program specifically to flat, smooth, and foam, we'll be using this foam material to go back to smooth as well as to flat. How will we be using that? Okay, so let's check out the foam material documentation. So we have this. Let's see if they have provided any documentation about it. Well, you can see like for flat shading, you can put like the flat shading value to like just true. So let's see that how that works. So sphere new, okay, sphere new dot material new, okay, dot material dot, what was that again? Um, flat shading, flat shading equal to true. Let's see how it looks now. So the flat shading is not working. Okay. So how do we change this flat shading to Lambertian shading? Okay, let's see in the documentation again. So for Lambertian shading, we know they don't have any specular surface, right? No specular surface. So how do we do it? Let's see where we are projecting the light. Uh, huh, here, specular highlight. So shininess, how shiny the specular highlight is. A higher value gives a sharper highlight. Default is 30. So think about it this way. What happens if I take this specular highlight to, don't know, like a really big value, let's say dot material dot specular, dot shininess, sorry, equal to, let's say 150. Let's see what happens now. Let's turn off flat shading. Actually, it's gonna be much better that way. Okay, we can see like the specular highlight is much more prominent now and much brighter, greater intensity. So think about it this way: if we set this to 0, what will happen? It would have no specular highlights. So what do we get then? A Lambertian surface, don't we? So this way you can use mesh foam material to get both smooth shading as well as flat shading. But for Lambertian material, you can't get the shininess because it doesn't have a specular surface. So if you use Lambert material, then you won't be able to get the foam specifications. But let's still see what would we get with Lambert. So for Lambertian material, mesh Lambert material, let's try this one. Mesh Lambert. True. Okay. It's not casting shadows because I turned it to off. But let's turn it to on. Okay, so we'll turn this off. I don't know if you can see this, but there's like a you see like what's happening here, right? So how do we turn that off? We just say sphere new dot receive shadow equal to false. So the sphere doesn't receive any shadows. Okay, that didn't change anything. Okay, so let's see in Mesh Lambert materials documentation what is actually happening here. So this one is calculating reflectance, simulate some surfaces. Okay, so this is doing the Gouraud shading model, vertex schedule. Okay, so interpolate result in polygon spaces per vertex. So it's actually checking per vertex. That's why we're getting this effect. Whereas if we do form here again, we don't have that per vertex calculation, so it's giving you a very clearer, smoother, much more prominent look. So you can, so from the looks of it, you can get a Lambertian surface like using Phong material. But if you want to get that vertex, like that effect that was happening, then you might want to use Lambert material. That would be a nice way to go. Yeah, so that would be all. Thank you so much for joining me and have a nice evening. Thank you.